Have you ever pondered over the concept of a minimum spanning tree in machine learning? It sounds like a term straight out of a fantasy novel, doesn't it? But it's actually one of the many fascinating concepts that form the backbone of the field of machine learning. Imagine you're an artist and you've been given the task of connecting a series of dots to form a beautiful picture. Now you can connect these dots in a myriad of ways, but you've been given one rule. You must use the least amount of ink possible. The solution to this problem is what we call a minimum spanning tree in the world of machine learning. It's the simplest, most economical way to connect all the dots or nodes in a network. A minimum spanning tree is a subset of the edges of a connected, edge-weighted graph that connects all the vertices together, without any cycles and with the minimum possible total edge weight. That's a mouthful, isn't it? Simplified, it's the tree connecting all nodes with the least overall cost. The concept of a minimum spanning tree is crucial in machine learning because it helps in the effective organization and classification of data. It's like a master key that unlocks the door to understanding complex data structures and patterns. One of the most popular algorithms to find the minimum spanning tree is Kruskal's algorithm. It sorts all the edges from the lowest weight to the highest, then it starts adding edges, and it keeps on adding the edges from the sorted list as long as the addition of the new edge does not form a cycle. Another popular algorithm is Prim's algorithm. It starts from a random node, then it keeps adding new nodes into the tree from the remaining nodes that have the least weight edge from the tree. These algorithms, and others like them, are the tools data scientists use to paint their pictures with the least amount of ink, or in other words, to organize and understand complex data in the most efficient way possible. To sum up, the minimum spanning tree is like the ultimate bargain hunter of machine learning, always looking for the most cost-effective way to understand and organize data. It's a concept that underpins many of the algorithms used in data science, helping to transform raw, unstructured data into meaningful insights. So the next time you see a series of connected dots, whether it's stars in the night sky or cities on a map, remember the minimum spanning tree. It's the invisible hand that guides the path of least resistance, a fundamental principle that helps us make sense of the world around us. And who knows, the next time you're faced with a complex problem, you might just find yourself thinking, what would the minimum spanning tree do